Before we dive in the concept of design patterns, let us take a look at what are design patterns, why do we need to learn them, and how can they help us become better programmers and increase our chance of getting hired in the game development industry. Well, design patterns are a set of rules that we use to help us write a readable and maintainable code. What does that mean? That means when we create a project and somebody else comes to take a look at our project, and that someone else is a programmer, not some random dude from the street, okay? And he takes a look at our project, he will be able to understand what the code is doing. Every single variable laid out, he will know based on the name of that variable, because we will be following some principles, what that variable is doing. Every function that we have, he will know what that function is doing, and he will not get lost in our code. And on top of that, if he wants to expand something in our game, maybe we have a character, he wants to add some more features to him, more powers and so on, he will be able to do that easily without breaking anything in the code. And more importantly than that, when you and me come back to the project that we created, so not you and me both, maybe you did create some project with me, I don't know. But anyways, the project that we worked on, and we come back to it after, I don't know, half a year, we will be able to understand our own project, and we will not get lost. Just think about it. How many times did you come back to a project that you created a month ago? Not more than that. And you had no idea what is going on and what's happening. Well, design patterns help us fix those issues. Now, of course, these are a set of rules that if you break them, programmers will come to your home and they will beat you up. But other than that, as time goes by and you become better and more experienced in code, you will know when to break those rules, because not every single time the design patterns that we have will help you achieve what you want to achieve. And the important thing is that you are a programmer on your own, which I teach you in my videos, especially in my Game Development Academy, how you can be an independent programmer and be able to solve the problems you face on your own and so on. So as I said, as time goes by, you will see where you actually need to break these rules sometimes in order to make some features for your game. And also I want to point out one thing, there are multiple design patterns. And in this course, we're not going to cover every single available design pattern out there. And not every design pattern is compatible with game development. But I'm going to cover the essential design patterns. And of course, as time goes on, the more I learn myself and discover new design patterns, I will add them to this course as well. So this is our basic introduction to what are design patterns, for what we're going to use them, and so on. So now we can jump over to the juicy part and start learning design patterns. The number one rule in programming that is there to help you avoid all the pitfalls and problems later on in your project is naming. And I don't mean like naming your child or your dog or whatnot. No, naming the variables and classes that you use. So you need to give meaningful and descriptive names to your variable so that you exactly know what that variable is for. For example, over here inside of this BP Fireball blueprint, I have the damage amount. It is clearly stating that this variable is used as a damage amount to deal damage to the enemy, to NPCs, to whatever. And over here in C++ as well, there you go, we have a float, movement speed, integer, damage amount, same thing. So this is there to help us know what are we going to use this variable for. So when we come back to this project, as I said in the introduction video, after 1 month, after 2 months, and I take a look at this variable, movement speed, I automatically know this variable is used for the movement of the character, of the enemy, of whatever. And this is a much better way than to use comments over here and you type this variable, I don't know, this variable is used for speed or whatever. So you give meaningful, self-describing names to your classes, to your interfaces, to your variables, to your functions as well. So for example, you might have a function attack and deal damage or something like that. So void deal damage. And automatically you know when you take a look at this function that it will deal damage. And all other functionalities that you will have. So make sure that you have that in mind when you are constructing your classes. So that is the most important thing that will help you avoid all the pitfalls. And you can take a look at online the naming conventions for C++ and stuff like that if you are new to C++. I personally tend to break these rules because in C++ you should start with capitals like this, movement speed. Sometimes I have variables like this, movement underscore speed. I don't care because I know for what they're used, and I, tend to break these rules as I mentioned in the previous video. So you will get to the point to know where you should break these rules, especially if you're working on your own projects, and that's still, self-explanatory. So if somebody comes and takes a look at this variable, movement underscore speed, he will still understand that this variable is used to move the character. So there you go. These are minor things that you will get used to or develop for yourself, because you will find programmers that are against this. I don't care. Every single programmer is on his own, and you get the point. So this is the essential part of design patterns, so to say. It's not part of design patterns, but as I said, it is there to help you avoid all the pitfalls later on in your project. The first design pattern that we are going to take a look at is the most notorious one, which is called a singleton pattern. And the reason why it is notorious is because it is globally accessible. And this contradicts to the programming philosophy, and the programmers of the underworld are going to, throw us in a dungeon or whatever. But anyways, it is a widely used design pattern in Unreal, in Unity, in other software development branches as well. So before we dive into the singleton pattern and see what it is, let us explain how it works. The idea behind a singleton is that we have an object that is a singleton, meaning it's single. And that doesn't mean it's not sexy and women don't want to be with it. No, this is programming. So no women, no single. But the idea is that we have a single instance of that object during the whole life cycle of the game. So we can turn on our game on our computer, and that instance, that singleton, will be created. If we play that game for 5 hours, 10 hours, 15 hours, and I know you don't say you don't play that much, during whole that gameplay, we only have one instance of that singleton. And why is this good? Well, the reason why is because we can have variables inside of that object that persist along with that object, and they can be globally accessible to all other objects inside of the game. So for example, it can carry the high score or the score from one level to another level. It can carry the player's life stats from one level to another level, and so on and so forth. And that is why singletons are very useful. And when it comes to Unreal Engine, there is a very neat and simple way how to implement a singleton. And first, we are going to take a look at how can we do that using blueprints. Over here, I have a simple blueprint which inherits an actor, which simply has a print message functionality. And I'm going to use this to demonstrate it. To create a singleton, I have used over here a blueprint that inherits from the game instance class, as you can see right here. And inside of that game instance, I have a variable which is a string type variable called message for printing, and I have a reference to the print actor, which is this bad boy over here, because we are going to use his functionality. Now, of course, we can also create the same functionality for printing the message within the game instance itself, but I'm going to show you how we can alter or change variables from different blueprints, so from other blueprints, and still print the same message using other objects. Because when you interact with a singleton, multiple objects will be interacting with your singleton, not only 1 or 2 or 3, maybe 10, 20, 30, I don't know, depending on your game and what you want to achieve. So as I said, over here we have that message for printing, which will be printed over here when we call print from actor, and over here when we initialize our game instance, I am getting a reference for the BP print that I have added over here inside of the level. Over here I have two other blueprints that are getting a reference to the game instance by using get game instance and then casting to my game instance, which is the custom one that we have created. Now over here we are changing the message, which is this right here. So this is the message that will be printed using the print actor, and we're changing that in BP test 1. So message set from tester 1, and then over here I'm saying passing string data, which is an arbitrary data that we are passing. And then from there also, as you can see, we are calling the print from actor functionality. After that, we're delaying for 8 seconds and then printing from actor again. We will see why we're doing that, because over here inside of BP test 2, first we are delaying for 4 seconds. Then we are getting a reference to the game instance, and from there I am printing first from the actor, and after that I am changing the variable, which is the message for printing inside of test 2. And over here, as you can see, message set from tester 2 passing integer data. What's gonna happen essentially when we run the game, first we are going to print to the screen over here from tester 1, and it is going to print this message. Then we are going to wait and then print again, but in the meantime over here we're also waiting and then printing to the screen, then changing the message. So let's see what's gonna happen. If I hit the play button, you will notice here at the top left corner, message set from tester 1, then again, message set from tester 1 passing data, and now we are going to see message set from tester 2 passing integer data. First it was string, and if you don't believe me, I'm going to stop this and let me just resize this window so I can see my stop button over here. So passing string data over here, and again we should see passing string data, there you go, and now we should see passing integer data. There you go. So what essentially this proves is that we can change the variables inside of the singleton or the instance. As you can see over here inside of test 1, this is the value that I have set for the string that will be printed. So over here I set message set from tester 1 passing string data, and then I have printed that to the console. In the meantime, I have delayed the execution from this blueprint, and then from there I have also printed, which will essentially print this same message. And then from that blueprint, when we print to the screen, we are changing the value of the message for printing, and then we are printing that over here after the delay of 8 seconds. The point is that we have changed this string over here inside of our test 1 and in test 2, and in both cases it has persisted across the level. Now, of course, you're not going to do something like this within your game. You're going to do something different, you know, passing probably score data, I don't know, the enemy count data. This is just on top of my head, you know. You need to be careful which variables you want to pass using a singleton, because you don't want to add something inside of the singleton that you don't need. The idea is that you have globally accessible variables within the singleton that are needed by other classes in the game or other blueprints within the game. That is the whole idea. So for example, if every level needs to know how many enemies are in that level, so the enemy count, then we can add that value inside of the game instance. And the idea behind the game instance is that we set it over here in project settings, and then we go into project maps and modes, and over here at the bottom where we have the game instance, this is where we set the game instance. Look at that over here. This is where we set the game instance, and it will be carried because the game instance by default with Unreal Engine is carried across the whole application, across the whole life. So I say application, but I mean game. But the point is, it is carried across the whole life cycle of the game. And no matter what you do, you cannot, destroy it or whatnot. You cannot even touch it. In order to access it, you need to call over here get game instance and then cast it into your desired game instance. Of course, over here also you're not going to do things like this. You're going to get a reference to the game instance from other blueprints where you need that reference in order to access the public variables that are created inside of the game instance itself. So anyways, if you have any questions in regards to this, make sure that you ask them in the comment down below, and I will see you guys in the next one. Let us now take a look at how can we create a singleton pattern using C++ programming language. So over here in my classes, I have my game instance class, which of course inherits from game instance. And if I open that class over here, you will notice it only has an F string, which is the message for printing, and it has a function that will print that message. If I go here in the implementation in the .cpp file, we're simply using UE-log to print out that message. Nothing complicated, nothing special. And also I did not pay attention to naming conventions. I simply named it my game instance. You would probably name it something else, meaningful or whatever, but you get the point. Going back to Unreal, inside of the blueprints, I have created here a blueprint called cpp_bp _ my game instance. So over here in test 1 and test 2, I'm getting an instance or a reference to the cppbp, and then I am changing the message for printing to test1 : passing string data, and then I am printing that out. After that, I'm delaying for 2 seconds and printing again. Over here in test 2, I will delay 1 second, then I will get a reference to the new game instance, and then I will print from it, and then I will change the message for printing. What this will do is the following. So over here first, I will get a reference to the game instance, set the message, and print this message. During that time, this wait or delay here will come to an end, and I will print from here, which will print exactly this message over here. And then while I am here in this delay waiting for 2 seconds, I will, after the print, I will change the message again. So changing the message in another completely different blueprint. And then when I come back over here, I will print, and it will print this changed message. So let's see how that looks like here in the output log. So I'm going to clear everything. If I hit the play button, we will notice here passing string data, then passing integer data. But over here, notice test 1, which is the initial data that we set. Then we have again printed from, test 1, which is, so this one over here is actually called over here. So when we call this print, then it is going to print this right here, but then it will change, you see, test 2 passing integer data, which is this one over here. Look at that. And this right here, the last print, is printed from here, from bp_test_1. So essentially we're changing the value of the message to be printed in test 1 and test 2, and then we are printing that message from both of these to see that the data is being persistent. It's in the singleton, and then it is accessible to every other object or class or blueprint inside the game. Now there is another thing that you might ask, okay, this is from blueprints, but how can I edit this from C++ code? Or how can we change the value, for example, of the message to print from C++ code? Well, over here, I have created a singleton test, which inherits from actor. And over here, I have a reference, or I have created a variable type of my game instance. And I also created a function that will print the message. Over here in the implementation, what I'm doing is, I have a function, this one over here, where I'm going to get a reference to the game instance, and this is all done in C++, and then from here I'm going to change the message for printing. You see here, printed from singleton, as you can see, and over here, custom game instance, and I'm calling the print from CPP, which will invoke this function over here. And inside of the begin play for this Singleton CPP, I am calling this function after a 4 seconds delay. So over here I have the timer handler that I'm going to get the time manager from the world and set the timer handle this, and then the function that I want to be executed, which is this one over here, and I'm simply going to move it on down one line so that we can clearly see what we have over here. And then after 4 seconds it is going to call this function, and we will see this right here printed from Singleton inside of the output. So let's go over here in the output console, and if I hit the play button, I'll actually, first things first, I have created a blueprint from the Singleton test, which is over here. So here is the blueprint from the Singleton test, BP Singleton test, and I need to put it over here, and then we can go inside of the output. And let me clear everything again, hit the play button. Let's pay attention. So passing string data, passing string data, passing string data, and actually integer is after that, and over here printed from Singleton. There you go, which is exactly this over here that we set inside of the CPP class, and then we call the function to execute or to do its functionality and whatnot, which happens over here again after, so where is it? Over here, after 4 seconds, and we see it clearly. So first we have from test 1 that we set passing string data, then we print that same value from test 2, but then we change the value in test 2, and then print that value from test 1. And last but not least, then we print the value from the Singleton, which we have also created as a blueprint because we need to create it as a blueprint in order to use it in our games. So this is about the Singleton pattern when it comes to blueprints and C++. If something is not clear when it comes to the C++ part, make sure that you ask. But essentially what this demonstrated is that we can have one variable. Let me just go here. It will be, more clear where I am going to draw. So the point is that we have one Singleton, and that Singleton has a variable. I'm going to call it V. And then we have here test 1, then we have here test 2, and test 1 can change this value. Let's say he sets that value to be equal to 2. If now test 2 tries to access that value, he sees that that value is equal to 2. And then he can change it, for example, and set that value to be equal to 3. So now the value is 3. And if T1 tries to get that value again, so now the value is not 2, but the value now is 3. And so on and so forth. And same thing happens from classes, from C++ classes as well. So again, if you have any questions in regards to the Singleton pattern and how to use it, if something is not clear from the demonstration, make sure that you ask in the comment down below, and I will see you in the next one. What you just saw is a slight preview of what awaits you in the course in my Game Development Academy that talks about design patterns for Unreal Engine with blueprints in C++. So if you want to learn more about design patterns, see different design patterns, how you can use them in your game, click the link down below and enroll in my Game Development Academy.